Okay, picture this. I want you to imagine yourself standing right at the very edge of space. You're zipped up in a highly advanced, practically indestructible spacesuit. And when you look down, there isn't any solid ground. Instead, you're looking at a mesmerizing, terrifying, swirling marble of orange, white, and red. You are staring down Jupiter, the undisputed king of our solar system. In this explainer, we're not just going to look at data from NASA's Juno spacecraft or the Hubble telescope from millions of miles away. No, we are going to actually experience it. We're taking a first-person journey straight down into the depths of the largest planet in our cosmic neighborhood. It's a question that feels like the ultimate setup to a sci-fi thriller, right? What actually happens if you fall into Jupiter? Well, we're going to plunge layer by layer into this giant, guided by the absolute latest scientific discoveries. We're going to experience the freezing upper atmosphere, navigate storm systems way larger than our entire planet, and dive into an alien ocean of liquid metal, all the way down to a 4 billion-year-old mystery at its very heart. It's a descent that will test the absolute limits of extreme physics. So take a deep breath, let go, and let's begin the drop. Now, the very first thing you need to wrap your head around is that your earthly intuition is completely useless here. There is no surface to land on. Because Jupiter is a gas giant, it's basically a colossal churning sphere of hydrogen and helium. You wouldn't fall onto Jupiter, you would simply fall into it, endlessly. On Earth, our atmosphere ends where the ground begins, but on Jupiter, the atmosphere just gets thicker, heavier, and hotter, until it fundamentally changes states of matter. There's no shore, there's no landing. There is only the descent. Part 1. The approach. Deadliest radiation in the solar system. Before we even brush against those beautiful, iconic clouds, we hit an invisible, completely lethal wall. The approach to Jupiter is honestly just as dangerous as the planet itself. We are entering an environment that is totally hostile to biology and machinery alike. You see, Jupiter generates an enormous, terrifyingly powerful magnetic field. It is roughly 20,000 times stronger than the magnetic field we experience here on Earth. This colossal field balloons out millions of miles toward the sun and extends this massive tadpole-shaped tail all the way out to Saturn's orbit. And this is exactly why we gave you that fictional indestructible spacesuit. This massive magnetosphere acts like a giant particle accelerator in space. It sweeps up electrically charged particles and whips them into high-energy frenzies, creating the deadliest radiation belts in our entire solar system. Without supreme protection, this intense radiation would completely destroy your spacecraft and you nearly 300,000 kilometers before you ever even saw a cloud top. It's literally a lethal, invisible shield. But our suit is holding up, so we punch right through. As we finally hit the upper atmosphere, your suit's heads-up display starts tracking the drop. You are falling fast. At T0, you drop through wisps of high, bright clouds made of ammonia ice crystals that sparkle like diamonds. It's eerily calm up here and freezing cold, about minus 150 degrees Celsius. About an hour in, the clouds thicken and start to warm up. You hit a layer of familiar water clouds. Right here, the pressure is about 1 bar, which is the exact pressure you feel standing at sea level on Earth. But enjoy it while it lasts, because that fleeting comfort vanishes quickly. 12 hours into your fall, sunlight is just a distant memory. It is pitch black, and the crushing pressure is building rapidly. Part 2. The storm zone. Winds, lightning, and chaos. That deceptive calm of the upper atmosphere is completely gone now, and you are surrounded by pure chaos. The winds down here are ferocious, driven by Jupiter's incredibly fast rotation. A day here is only about 10 Earth hours long. To truly understand the scale of what we're dealing with, let's contrast this with Earth. Our entire weather system is incredibly shallow. It only extends about 30 miles deep. Jupiter's weather makes a complete mockery of that. NASA's Juno spacecraft took gravity measurements that revealed Jupiter's colossal storm belts penetrate a staggering 3,000 kilometers deep into the planet. You are falling through an endless, churning ocean of violent atmospheric fluid dynamics. Suddenly, lightning illuminates the dark, lightning 1,000,000 times stronger than anything on Earth, and it reveals some bizarre phenomena falling right alongside you. Scientists call them mushballs. They're these slushy spheres of water and ammonia. But if you look deeper, the science gets even wilder. Based on strongly supported hypotheses, in these lower crushing layers, the intense lightning breaks down methane gas into soot. As that soot falls, the immense pressure literally compresses it into actual diamonds. It is raining diamonds into the abyss. These diamonds plummet deeper and deeper until the intense heat eventually melts them into a liquid diamond sea. But let's go back to those mushballs for a second. How do those storms actually work? Well, local thunderstorms lift water ice up from the deeper layers. Once in the high cold altitudes, this water mixes with ammonia gas. This mixture acts kind of like antifreeze, melting the ice into a liquid slush to form these heavy hail-like mushballs. Because they're so incredibly dense, they plummet straight back down. The absolutely crucial takeaway here is that these mushballs act as giant atmospheric vacuum cleaners. They drag the ammonia gas out of the upper atmosphere and carry it deep into the abyss, creating a bizarre, completely localized weather cycle. Part 3. The Great Red Spot, a storm larger than Earth. As we continue our fall, we start getting pulled into the perimeter of something truly legendary, the Great Red Spot. This is a high-pressure storm so massive it could literally swallow the Earth whole. What we see through telescopes from Earth is really just the tip of the iceberg. Using Juno's microwave radiometer and gravity data, scientists managed to peer beneath the cloud tops. And what did they find? They discovered that the roots of this single storm plunge an astonishing 500 kilometers deep into the Jovian atmosphere. And despite centuries of humans observing it, this storm is still full of surprises. Just recently, in late 2023 and early 2024, the Hubble Space Telescope focused on the Great Red Spot for 90 days. The time-lapse data revealed something completely unexpected. This giant storm is not stable. It's actually wobbling. Astronomers described it as jiggling like a bowl of gelatin, oscillating in its elliptical shape as it pushes against the incredibly powerful jet streams to its north and south. So even after hundreds of years of study, Jupiter refuses to be predictable. Part 4. The Abyss. Swimming in liquid sky. We are finally leaving the storms behind and entering the true deep. Your endless fall is starting to slow down. It feels way less like falling through air now and more like sinking through an incredibly heavy, wet fog. At this point, you have traveled less than 1% of Jupiter's radius, but the environment is entirely alien. The pressure is a suffocating 1,000 bars. That's 1,000 times heavier than Earth's atmosphere. The temperature is a searing 1,000 degrees Celsius. Under these extreme conditions, hydrogen stops acting like a gas altogether. The intense pressure squeezes the molecules so tightly together that the atmosphere smoothly transitions into a superheated, boundless fluid ocean. You are now swimming in liquid sky. But we're going deeper still, to a depth of more than 3 Earth diameters. And here, the physics get truly wild. The pressure skyrockets to 2 million bars, and the temperature hits 10,000 degrees. The extreme pressure violently squeezes the hydrogen atoms until their electrons actually just break free. This liquid hydrogen can now conduct electricity. It has become a glowing, alien substance, liquid metallic hydrogen. This swirling, electrically charged metal fluid acts as a massive dynamo inside the planet, and is exactly what generates that deadly 20,000 times stronger magnetic field we had to cross to get here in the first place. Part 5. The Core, the 4-billion-year-old mystery. Finally, we reach the heart of the giant. This is a place that has remained a profound mystery to science for decades. The very limits of extreme physics are tested here at Jupiter's core. The numbers honestly just defy human comprehension. The pressure is estimated to be around 45 million bars. To even try and visualize that crushing force, I want you to imagine the weight of 1,000 full-grown elephants, all perfectly balanced on the tip of a single stiletto heel. That is the pressure pressing in on you from every possible direction down here. And the heat? It's sitting at roughly 30,000 degrees Celsius. Think about that for a second. This pitch-black abyss deep inside a gas giant is actually significantly hotter than the surface of the sun itself. It is a literal cauldron of primordial energy left over from the planet's original formation. For a really long time, scientists just assumed Jupiter had a small, neat, solid, rocky core right at its dead center. But Juno's gravity data completely shattered that assumption. Instead, the core is much, much larger than expected, and it's not a solid sphere at all. It's partially dissolved. The rock and ice are mixed right into the metallic hydrogen, creating this dilute, fuzzy core with no clear boundary whatsoever. It's just a murky, swirling mixture of heavy elements. But this fuzzy core is more than just an extreme environment. It's a pristine time capsule. It's holding on to the original debris of ice, rock, and metal from the absolute embryonic days of our solar system, trapped under millions of bars of pressure for 4 billion years. By looking at the heart of Jupiter, we are literally looking back in time to the very birth of our planetary neighborhood. It helps us understand our own origins. So, to answer our initial question from the beginning, no, you would never survive the fall.
You'd be irradiated, crushed, battered by mush balls, and dissolved in an ocean of liquid metal. But here is the ultimate twist, and why this matters so much to us on Earth. Jupiter's massive gravity acts as a cosmic vacuum cleaner. It is so massive you could fit 1,300 Earths inside it, and it uses that immense gravity to capture or deflect dangerous asteroids away from the inner solar system. The planet that would instantly destroy you is actually the silent protector of Earth. You never survive the fall, but without Jupiter, none of us would be here.